Hey everyone, this is Bhargav Sudhar, and today we are continuing with the topic relations. Now in this session we will discuss the types of relations, that are the inverse, complement, composition of a relation, and some other types. So first let us discuss what is inverse relation or the converse relation. Now if R is a relation from A to B, then its inverse relation of R, it is denoted by the symbol R inverse, and it is a relation from B to A. So if R is a relation from A to B, then its inverse relation will be from B to A. Okay. Now this R inverse is defined as set of all yx such that y belongs to B. So that means second element comes from B, first element comes from A. Okay, and obviously this x and y belongs to R, so that means x has to be related to y. So if x and y belongs to R, that is x is related to y, then we can say that y R inverse x or yx belongs to R inverse. So that means y is inversely related to x, or yx belongs to simply R inverse. Now the inverse relation is also known as the converse relation, and hence sometimes it is denoted by the symbol RC, R raised to C, but we will use the inverse relation, so that means dash symbol. Now for example, if R is a father relation on a set S equals to F, M, B1, B2, S1, then now what will be the relation? R equals to, see, we have here the father relation. Now F, M, B1, B2, S1, they stands for, F stands for father, M stands for mother, B1, B2, they are sons or brothers, and S1 stands for daughter or sister, S1. Now the father relation, that means FB1, so F is a father of brother 1, F is a father of brother 2, and in same manner F is a father of sister 1, so FS1. Okay, so in the relation R, it will be like this. Now let us calculate how to find the inverse. So then the inverse relation of R, it can be a son relation or a daughter relation. So what will be the son relation? R1 inverse. It will be like this. See, B1F and B2F. As B1, the brother 1, he is a son of F, that is father, and in same manner B2, brother 2 is a son of father F. So that is a son relation. And in same manner R2 inverse. So that is, it will contain only one element S. S1, sister 1, she is a daughter of father F. So that is a daughter relation. Let us take another example. If A equals to A1, A2, A3 and B equals to 1, 2. Okay, then the relation R, that is A11, A22, A32 is defined from the set A to B. So that is A1, A2, A3, 2, 1, 2. So then the inverse relation will be like this. So R inverse, and that is 1A1, 2A2 and 2A3, and it is defined from B to A, and we are just changing the order, so that will be the inverse relation. Now let us take what is the complement of a relation. So let capital A and capital B be two non-empty sets. A relation R from A to B is defined as this R equals to AB such that A belongs to A and B belongs to B. We all know this. Then the complement, and it is denoted by this R dash, is defined as R dash equals to set of all AB such that this AB does not belongs to R. So that means A is not related to B. Just collect all those elements in which A is not related to B. That is, A is R dash related to B if and only if A is not related to B. Let us take results. Now R1 union R2 dash equals to R1 dash intersection R2 dash. And in same manner, if we change the order, you will get R1 intersection R2 dash equals to R1 dash union R2 dash. You must have seen this type of results in set theory or something, and just think about it. What is that result? Yes, you are right. It is the De Morgan's laws, and it is also true for this relation. Now let us take composition of a relation. Let capital R1 be a relation from A to B and R2 be a relation from B to C. So here we have two relations. One is from A to B and another one is from B to C. So we have two relations and three sets. So then the composition or composite relation will be from A to C, and it is denoted by this R1 dot R2 or simply R1 R2, and it is defined as, see, R1 equals to R2, and that is set of all AC such that this A belongs to A, C belongs to C, and B belongs to B such that this AB belongs to R1. So that means A is R1 related to B and B is R2 related to C. So we will see the example so that you will get the idea. So let us take example how to calculate a composition of a relation. So let A equals to 1, 2, 3, 4 and 5. Okay, so R1 is given and R2 is given. Okay, so R1 is 1, 2, 1, 3, 2, 4, 3, 5 and R2 is given 3, 2, 4, 5, 5, 1. Now we need to find R1 dot R2 and R2 dot R1. So first, what will be the R1 dot R2? So it will be like this. Now how to calculate this? Okay, so first see, for R1 R2 just consider the first pair 1 2. Now 1 is related to 2. Now check in R2. Okay, so R2, now 2 is related to which point? But you can see that 2 is related to none of the points. Okay, so just leave that pair. Now just go to 1 3. Okay, for 1 3 we are just understand 3 points 1 3 and 2. So you can see that in R1 1 is related to 3. So okay, so 1 is related to 3. Now for 3, now in R2 3 is related to which point? Now you can see that 3 is related to 2. So now 3 is related to 2. So the final answer, so final pair for R1 R2 will be what? 1 is related to 3 and 3 is related to 2. So the final pair will be 1 2. Okay, so you can see that in R1 R2 the first pair is 1 2. Now okay, now take 2 4 in R1. Now 2 is related to 4. Now check in R2. Now 4 is related to which point? That is, here you can see that 4 is related to 5. So 2 is related to 4 and 4 is related to 5. So 2 5 pair will be there. Now in same manner, consider 3 5. So 3 is related to 5. Now in R2, check 5 is related to which point? So you can see that 5 is related to 1. So 3 5 5 1. So 3 1 pair will be there. So that's it. So 3 1. So this is how you can calculate R1 R2. Now let us calculate R2 R1. So this will be the answer. How? Now for R2, just consider the first pair of R2, that is 3 2. Now 3 is related to 2. Now check in R1 that 2 is related to which point? Now 3 2. Now 2 is related to 4. So 3 is related to 2 and 2 is related to 4. So 3 4 pair will be there. Now in same manner consider 4 5. Now 4 is related to 5. Now check in R1 5 is related to which point? But here 5 is related to none of them. So just leave that pair. Now 5 is related to 1 in R2. Now check in R1 1 is related to which point? Now as you can see that 1 is related to 2 as well as 1 is related to 3. So we will consider both the points. So 5 is related to 1 and 1 is related to 2. So 5 2 pair will be there, and in same manner 5 1 1 3. So 5 3 pair will be there. So this is how you can calculate. Okay. Now see, as you can see that R1 and R2 and R2 R1 both are different. So R1 R2 does not equal to R2 R1. Okay. So that means this composition of a relation is not commutative. So if you change the order, you will get the changed answer. Now what is a relation in a set? Let capital A be a relation from A to itself. Then R is a relation in A. So that means both the sets are same. So we can say that it is a relation in a set A. So that is R is a subset of A cross A. Now let us consider what is the identity relation. Now let capital A be a set. Now the relation IA, I stands for identity. So IA is defined by the IA equals to set of all AB such that this A belongs to A, B belongs to B and A equals to B. Then is called the identity relation. Thus the identity relation in a set is the set of ordered pair AB of the A cross A for which both the sets are same. For example, so is consider this A equals to 1 2 3 4 5. Okay, both the sets are same. Then what will be the identity relation? It will be like this. This 1 is related to itself, 2 is related to itself, 3 is related to itself, and so on. So 1, 1, 2, 2, 3, 3, 4, 4, 5. This will be it. Now, what is a universal relation in a set? So let capital A be any set and R be any relation on a set A. So by the definition, R is a subset of A cross A. Now, what is a universal relation? So if this whole relation equals to A cross A, then it is known as a universal relation. So that means whatever we are finding the relation, if this whole relation is same as this ordered pair A cross A, then we will get the universal relation. Now, what is a void or empty relation? Just by its name, it will be empty. Let us take now a relation R on a set A is called void relation if no element of a set is related to any element of A. So that means this R equals to 5. Thank you.